Yes, a subpanel can be rated the same as the main panel. For example, a 200 amp main panel can indeed have a 200 amp subpanel. The National Electrical Code, or NEC, covers subpanels extensively, primarily within Article 384. Although Article 384 no longer exists in current National Electrical Code editions, the provisions formerly contained within it are now distributed among various sections of Article 408, specifically addressing switchboards, switchgear, and panel boards. These regulations are designed to ensure safe and effective installation and operation of electrical panels. Let's delve into some key areas addressed within the National Electrical Code concerning subpanels, reflecting the modern arrangement of these requirements. Firstly, consider the number of overcurrent devices on branch circuits and feeder circuits. The code limits the number of overcurrent devices that can be installed in a subpanel. This limitation is designed to prevent overloading and ensure that the panel can safely handle the connected circuit. Secondly, the arrangement of overcurrent protection devices in subpanels is carefully specified. The code mandates how these devices must be organized within the subpanel to facilitate easy identification and access, as well as to maintain optimal performance. Thirdly, the code addresses busbars and connections. It provides detailed requirements for the construction, installation, and connection of busbars within subpanels, ensuring they are adequately sized and securely connected to carry the intended current load. Additional considerations are also vital. The total capacity of the subpanel should not exceed the capacity of the main panel. This prevents the subpanel from drawing more power than the main panel can safely supply, which could lead to overloading and potential hazards. The breaker in the main panel that supplies the subpanel should be sized to protect the subpanel. This means that the breaker's amperage rating should be appropriate for the subpanel's capacity, tripping if the subpanel attempts to draw excessive current. The wiring from the main panel to the subpanel must be sized appropriately for the subpanel's capacity. The wire gauge must be sufficient to carry the intended current without overheating, complying with NEC Table 310.16 or other applicable tables. To elaborate further on the modern National Electrical Code provisions that relate to subpanels reflecting the updates since Article 384, consider the following. Firstly, Article 408 encompasses switchboards, switchgear, and panel boards, addressing the construction and installation requirements for these components. Panel boards, which include subpanels, must meet specific standards for enclosures, wiring space, and component mounting. Secondly, overcurrent protection is a critical aspect covered throughout Article 408. The code specifies requirements for the type and size of overcurrent devices, such as circuit breakers and fuses, to protect branch circuits and feeders connected to the subpanel. This includes ensuring that the interrupting rating of the overcurrent devices is sufficient for the available fault current at the panel's location. Thirdly, grounding and bonding are essential for electrical safety, and Article 250 of the National Electrical Code provides comprehensive requirements for grounding and bonding electrical systems. Subpanels must be properly grounded to the grounding electrode system, and all metallic enclosures and non-current carrying metal parts must be bonded together to create a low impedance path for fault current. Fourthly, wiring methods are also important to be aware of. Chapter 3 of the National Electrical Code covers wiring methods and materials, including the types of conductors, cables, and raceways that can be used for wiring subpanels. The wiring must be installed in accordance with the code requirements for ampacity, derating, and protection from physical damage. Fifthly, working space around electrical equipment is critical for safety and accessibility. Section 110.26 of the National Electrical Code requires sufficient working space around electrical equipment, including subpanels, to allow for safe operation, maintenance, and inspection. The working space must meet minimum dimensions for height, width, and depth, depending on the voltage and configuration of the equipment. Sixthly, labeling and identification are also vital for proper maintenance and troubleshooting. The National Electrical Code requires that all electrical equipment, including subpanels, be properly labeled to indicate their purpose and function. Circuit breakers and other overcurrent devices must be identified with labels that correspond to the circuits they protect. The code also requires that voltage and current ratings be clearly marked on the equipment. Here's a more detailed look into the considerations for sizing the sub-panel feeder conductors and overcurrent protection. Firstly, conductor ampacity is paramount. The conductors feeding the sub-panel must have an ampacity equal to or greater than the rating of the sub-panel's main breaker or the calculated load, whichever is higher. National Electrical Code Table 310.16 is commonly used to determine the ampacity of conductors based on their size, insulation type, and temperature rating. Secondly, overcurrent protection requirements must be met. The overcurrent protection device, typically a circuit breaker in the main panel, must protect the feeder conductors from overloads and short circuits. The breaker's amp rating should not exceed the conductor's ampacity unless specific exceptions apply, such as the NEC standard overcurrent device rule. Thirdly, the NEC size up rule allows for the use of the NEC's highest standard overcurrent device rating if the conductor ampacity does not exactly match a standard breaker size. However, this rule has limitations and should be applied carefully, ensuring that the conductor is still adequately protected. Fourthly, voltage drop considerations are also important. Voltage drop can affect the performance of equipment connected to the sub-panel. The National Electrical Code recommends limiting voltage drop on feeder and branch circuits to 3% for power, heating, and lighting loads, or 5% total voltage drop from the source to the farthest point of utilization. Fifthly, the calculated load of the sub-panel is important to understand. The calculated load is the total amount of power that the sub-panel is expected to draw under normal operating conditions. This calculation should include all connected loads, such as lighting, appliances, and equipment, taking into account any demand factors or diversity factors that may apply. Sixthly, derating factors must be considered. Derating factors may need to be applied to the conductor ampacity based on factors such as ambient temperature, the number of conductors in the raceway, and the presence of harmonic currents. These factors can reduce the conductor's ability to dissipate heat, requiring a larger conductor size to maintain adequate ampacity. Now let's delve into the grounding and bonding requirements as they relate to sub-panels, adhering to National Electrical Code Article 250. Firstly, the grounding electrode system is a critical component. The sub-panel must be connected to the grounding electrode system, which typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. This connection provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Secondly, the equipment grounding conductor, or EG, is essential. The EGC is a conductor that connects the metallic enclosures of electrical equipment, including the sub-panel, to the grounding electrode system. This conductor provides a low impedance path for fault current, minimizing the risk of electric shock. Thirdly, bonding requirements must be met. Bonding involves connecting all metallic enclosures and non-current carrying metal parts together to create an electrically continuous path. This ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock. Fourthly, isolated ground receptacles may be used in certain applications. Isolated ground receptacles have a separate grounding conductor that is isolated from the equipment grounding conductor. These receptacles are often used in sensitive electronic equipment to minimize noise and interference. Fifthly, ground fault circuit interrupters, or GFCIs, are vital for personnel protection. Ground fault circuit interrupters are required in certain locations, such as bathrooms, kitchens, and outdoor areas, to protect against electric shock. GFCIs monitor the current flowing through a circuit and trip if they detect a ground fault, which is a leakage of current to ground. Sixthly, surge protection devices, or SPDs, can protect against voltage surges. Surge protection devices are designed to protect electrical equipment from voltage surges, which can be caused by lightning strikes, power grid switching, or other events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. When installing a sub-panel, It's also important to consider the physical location and working space requirements as outlined in the National Electrical Code. Firstly, accessible location is crucial. The sub-panel should be installed in a location that is easily accessible for maintenance, inspection, and repairs. It should not be located behind obstructions or in areas that are difficult to reach. Secondly, dedicated space must be available. The area around the sub-panel should be kept clear of obstructions to provide adequate working space. This space should be large enough to allow electricians to safely work on the panel without being hindered by other equipment or updates. Thirdly, proper illumination is essential. The area around the sub-panel should be well lit to ensure that electricians can see clearly when working on the panel. This can be achieved by installing adequate lighting fixtures or using portable work lights. Fourthly, environmental conditions should be considered. The sub-panel should be installed in a location that is protected from moisture, dust, and other environmental factors that could damage the equipment. If the panel is installed outdoors, it should be housed in a weatherproof enclosure. Fifthly, the height of the panel is important. The sub-panel should be mounted at a height that is convenient for electricians to work on. The top of the panel should not be too high to reach comfortably, and the bottom of the panel should not be too low to the ground. Sixthly, clear access pathways are vital. There should be clear access pathways to the sub-panel to allow electricians to easily move equipment and materials to and from the panel. These pathways should be free of obstructions and wide enough to accommodate the largest pieces of equipment that may need to be moved. Let's discuss the importance of proper labeling and circuit identification in sub-panels to ensure safety and ease of maintenance. Firstly, circuit directory is vital. A circuit directory should be provided inside the sub-panel, listing the purpose of each circuit breaker or fuse. This directory should be accurate and up-to-date to allow electricians to quickly identify the circuit that controls a particular load. Secondly, permanent labels are required. All circuit breakers and fuses should be labeled with permanent markers or labels that clearly indicate the circuit they protect. These labels should be resistant to fading and damage to ensure that they remain legible over time. Thirdly, consistent labeling conventions should be followed. A consistent labeling convention should be used throughout the electrical system to avoid confusion. This convention should be documented and made available to all electricians who work on the system. Fourthly, voltage and amperage ratings should be clearly marked. The voltage and amperage ratings of the sub-panel and its components should be clearly marked to prevent overloads and other hazards. This information should be easily visible and legible. Fifthly, warning labels are required in certain situations. Warning labels should be used to alert electricians to potential hazards such as high voltage or the presence of energized components. These labels should be prominently displayed and easy to read. Sixthly, updated labels should be used after any modifications. After any modifications or changes to the electrical system, the label should be updated to reflect the new configuration. This ensures that the labels remain accurate and reliable. Now, consider some common mistakes to avoid when installing sub-panels to ensure safe and code-compliant installation. Firstly, undersized conductors are a common error. Using conductors that are too small for the intended load can cause overheating and fire hazards. Always ensure that the conductors are sized appropriately for the sub-panel's capacity and the loads they will be serving, consulting National Electrical Code Table 310.16. Secondly, improper grounding and bonding is another critical mistake. Failure to properly ground and bond the sub-panel can create a shock hazard. Follow the National Electrical Code Article 250 requirements for grounding and bonding to ensure safe installation. Thirdly, overfilling the panel with too many circuits should be avoided. Overcrowding the sub-panel with too many circuits can make it difficult to access and maintain the panel. It can also increase the risk of overheating and other problems. Fourthly, mixing different types of breakers is a mistake. Using circuit breakers that are not compatible with the sub-panel can create a safety hazard. Always use circuit breakers that are specifically designed for the panel. Fifthly, failing to properly tighten connections is a common mistake. Loose connections can cause overheating, arcing, and other problems. Always tighten all connections to the specified torque using a torque wrench. Sixthly, neglecting to label circuits is a common oversight. Failing to properly label the circuits in the sub-panel can make it difficult to identify and troubleshoot problems. Always label each circuit clearly and accurately. To summarize, always remember that a sub-panel can indeed be rated the same amperage as the main panel, provided that all applicable National Electrical Code requirements are met. Pay close attention to conductor sizing, overcurrent protection, grounding, bonding, working space, labeling, and other critical factors to ensure a safe and compliant installation. Always consult with a qualified electrician if you have any questions or concerns.